Hi class, in this video I'm going to show you how to solve an inventory problem, inventory management problem, and the model I'm going to use is the EOQ, which is the economic order quantity. Okay, um, the economic order quantity uses these formulas. This is the total annual cost. And this is the ordering cost. That's the cost to place orders during one entire year. This is the cost of holding units in inventory during one entire year. And this is the optimal quantity to purchase every time the purchasing person place an order. Every time the company place an order, this is the quantity the company should place for the supplier in order to economize the costs. This function, this formula economizes the holding cost and the ordering cost. As you can see in this chart, we have this 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 line shows the holding cost. The bigger the quantity, you see this axis increasing the quantity increases the holding cost. So the more quantity in inventory, higher the holding cost. Okay. Um, On the other hand, the lower the ordering cost for higher quantities, okay? Because you place less orders, the more you buy less time, less often, less frequent. So you don't have to place too many orders if you buy a big bulk. However, you have to hold these units for too long. So they're opposite. When as ordering a lot, you've reduced the ordering cost because you don't have to place too many orders, but then you have to carry too much in inventory. And on the opposite, you don't have too much holding cost because imagine you're placing an ideal, like imaginary hypothetical situation, you place order of one unit. Every day you place one order of one unit. You don't hold any unit in inventory, but you place too many orders, so the holding cost is low, but the ordering cost is high. So there is a point, an optimal point that minimizes these two costs of ordering and placing orders. That's the optimal order quantity, which is this Q here. This is giving us the optimal order quantity, the optimal order to buy every time the company purchases. Okay, and this is the reorder point. This lowercase d is the daily demand or weekly demand or monthly demand times the time it takes to get the order. Okay, the capital letter D is the annual demand. Okay, let's see an example here, a problem. Find the economic order quantity and the reorder point given the following information. So we have information here. Let me take note about this information. We have, let me go here to Excel. We have our D, which is, I don't remember, 10,000 units, right? 10,000 units. The ordering cost as the cost to place an order is 75. Let's put here dollars per order. Here is 10,000 units per year. I'm gonna put these units to help clarify what these letters are, what they represent. Annual holding cost is $6 per unit. We always need the holding cost is always dollar per unit, dollars per unit. In the next problem, the holding cost is going to be a percentage. Then we have to turn into dollars per unit. I'm going to show in the next example. Okay. What else? Lead time is 5 days. Lead time is 5 days. Oops, 5. Let me put it here, 3 days. And the company operates 250 days a year. So let's see. Let's call it the year. Or call the year. Let's call the year 250. It helps to tell us how many days the company operates. And why is that information important? Why this information is important is because I need to compute my daily demand to be able to compute the reorder point, okay? So how much is gonna be my daily demand? Is gonna be my annual demand divided by the number of days the company operates. Why is it taking too long? Okay. So, okay, if I divide the annual demand by the number of days the company operates, I have the daily demand. Let's put D is the daily demand in units, okay? Okay, we got it. Now let's compute. What the problem is asking? Economic order quantity. I'm gonna go back to the formula so you can see this is the economic order quantity. Okay, I'm gonna implement this formula in 2 steps to make it easy for students to see. Okay, first I'm gonna do 2SD divided by age, which is inside the square root. Okay, is equal. I'm gonna open parentheses 2 times the cost to place orders times the annual demand. Why is not okay? Times the annual demand. Again, the 2 times S, which is the um, cost to place orders, order cost, ordering cost times the annual demand divided by my age. Remember to close parentheses. So you can tell Excel everything that is in the numerator position is this, like in here, numerator divided by the, so now I have to take the square root, okay? To take the square root, I'm gonna use the function sqrt, open parenthesis, and then I select this number, which is inside the my square root, okay? So that's my optimal order quantity. Let me put here. This is my Q, optimal order quantity. Every time the company orders, it should order 500 units to maximize the economy. Okay, this is our Q, 500 units. Every time the company orders, it should order 500 units. Okay, that's the Q. Now the reorder point. The reorder point is telling us when we have to call supplier and place the order. That's the reorder point. I'm going to show you after I get that. So the reorder point is D, the lowercase d times, let's do times L. Okay. This is going to be equal my daily demand in units times the number of days it takes to get the shipment. These two let's say these two variables have to be in the same units. So if this is in days, this should be in days. If this is in weeks, this should be in weeks. If this is months, this should be months. Okay, so that's 200 units. Let me do this. This is the reorder point. Every time my inventory reaches 200 units, then I place a new order of 500 units. Okay? Why 200 units? Because, let me do this. So maybe you can see better here. Okay? So, because 200 units, imagine if it takes 5 days and every day I consume 40 units every day, then I have to wait 5 days to get the shipment. I'm going to consume 200 units. So how this works? I place an order of 500. My inventory goes up 500 units. Then I start consuming the inventory. And then it's consuming 400 units, 300 units. When my inventory reaches 200 units, I call my supplier and tell my supplier, send another shipment of 500 units. Then boop, 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 boop. my shipment comes, my inventory goes up again, and then I start consuming 400 units, 300 units. When it reach 200 units, that's my reorder point. I call back, I call again, and ask my supplier another 500 units. I keep using the units until the shipment comes, and then when shipment comes, that's what the policy is doing. The policy is economic, or the policy is telling us to purchase 500 units every time we place an order. And when we have to place an order, when our inventory level reaches 200 units, okay? Let's see the other example, the next example, and then it's over. It's not that difficult, okay? We have a problem here. Tacky Souvenirs sells lovely handmade tablecloths at this island store. These tablecloths cost tacky $50 each. So let's start taking notes. Let me open a new one here. I made it big for you to see. So let's see. Let's call C the cost to buy dollars per unit. That's the cost to buy the cloths. I don't know how to say that in English. Well, how did I go? Okay. Um, tablecloths. Okay. Customers want to buy the tablecloths. Okay, at a rate of 240 per week. So this is 240 per week. So this is lowercase d because it's not year. Okay, so it's 240 units per week. Okay, let's go to the other information. The company operates 52 weeks per year. The problem is telling the year has 52 weeks because now we have to compute the uppercase D because I know the weekly demand and I operate 52 weeks. So my annual demand is everything I sell per week times the number of weeks per year. That's my units per year. Okay, my per year, my demand, my annual demand. Okay, so far so good. Techie, the owner estimates his ordering cost at $50. So the cost to place an order is $50 per order. Per order. Now comes the holding cost. Annual holding costs are 20% of the unit cost. This is the unit cost. Let's compute it. So age is 20%. Okay, so it's 0.2, 20% times $50, $15. That's $3 per unit. Remember that my holding cost has to be in dollars per unit. In this problem, I just have the percentage as percentage of the cost. So I compute and get the dollars per unit. The lead time is 2 weeks. Lead time, 2 weeks. Okay, so let's go to the problems. Calculate the economic order quantity. EOQ, I'm going to do the same thing. I'm going to first do 2 times S times D divided by age. So I do here equal, open parentheses, 2 times my ordering cost times my annual demand divided by age. Okay? I divide by age, I forgot. Divide by age. Age is here, not HD. The number corresponding to. All right. So now take the square root of this big number. That's my 2 times S times D divided by. Okay, so this is the quantity. Let me put my optimal order quantity. This is my Q, my optimal order quantity. I explained before. I'm not going to explain again. Calculate the total annual cost. Let's go back to here. This is the total annual cost, the cost to place an orders and the cost to holding units. So let's do it. Total order cost. Let's do once total order cost. Yeah, let's compute the total order cost first. The total order cost is the annual demand divided by the quantity I place every time. That gives me how many times I'm going to place orders, right? The annual demand. And every time I purchase 644 units, then it gives me how many times I have to place orders. And I'm going to multiply by the cost to place orders. Okay, so it's Q, it's annual demand divided by Q. The annual demand divided by Q times S. Okay, I'm going to implement opening parentheses here. Then I'm going to get the annual demand divided by my optimal order quantity times this one gives me the number of orders per year. Okay, this gives me the number of orders per year. Number of orders per year. Then if I multiply by 50, I get my total order cost. Okay, let's do it again to make it clear. Let's put it here. How many orders in a year? How many orders in a year is equal to my my annual demand divided by my optimal order quantity. I'm gonna place 19, almost 20 orders per year. Okay. All right. My total holding cost. My total holding cost. Let's go back to here to look is my optimal order quantity divided by 2, my average inventory divided by the holding cost. So let's do is Q divided by 2 times age. I'm going to implement very carefully. This is going to be, I'm going to open parentheses, my Q divided by 2 times my holding cost. You see that these two are the same numbers? I'm going to reduce the decimal. I'm going to put it like this. It is designed to be the same. They should be the same, always be the same. Why? Remember this. This is reducing the cost to the minimum. And at this minimum for both, they have the same values, the minimum cost for both. That's the reason both have the same number. All right, so if we come back here, this is the total annual cost of placing orders and holding without the cost of purchasing. So let's make it very clear. Total annual cost without the purchasing cost, okay? So this total annual cost is going to be equal to this total holding cost plus the total ordering cost. That's my total annual cost without purchasing cost. What is the purchasing cost? Is the cost of buying the units. If I have this amount of demand and it costs $15 each, I'm going to compute now. Let's put it here like purchasing cost. My purchasing cost again is going to be my D times my C. That's my annual demand. I have to buy 12,480 units, paying $15 per unit. So that's going to be my total purchasing cost, okay? That's my total purchasing cost. What is my total? Now my total annual cost with the purchasing cost. My total annual cost, including the purchasing, is going to be my annual cost without purchasing plus the cost of the purchasing. Okay, so that's how much the company is going to spend per year. 189 $189,134. Okay, two total annual cost, one without the purchasing and one with the purchasing. Now my reorder point. Okay, reorder point, remember, is my daily or weekly or monthly demand times my lead time. So what I have to do here is check if this demand is per week, this lead time is per week, is good. If they're not in the same units, we have to transform them and put them in the same units. So here they're in the same units. What I have to do is 204 units times 2 weeks. So if I have to wait 2 weeks and every week I consume 240 units, waiting for the shipment, I need 480 units. Okay. So my inventory policy is going to be this. Listen, my quantity every time I purchase every time I place an order, my policy says you have to buy 645 units. Okay, so the manager, the purchasing person, whoever is purchasing, doesn't have to think how many units. The math is telling, the policy right is written is saying buy 645 units. Okay, when I have to buy it again, well, you keep checking inventory. 645, 500, 400, 480. When it reaches 480 units, you place a new order. Okay? Then while you wait for the order to come, it's going to consume the 480 units. And then when the shipment comes, you stock up again. 645, and then you keep counting. When we reach 480, you place an order. So the policy is telling us the amount to order and when to order. Okay, that's it.